Hello everyone, good to see you again. This video is for lab number 4, Logistic Regression in Spss. And as you can see in the title of this lab, in this video, and in this lab, we are gonna use SPSS software as well as the Microsoft Excel. So if you've not yet installed SPSS on your machine, so please pause this video, and then just refer to our course syllabus and install SPSS software on your machine, and then come back to the video and follow the direction to finish this lab. All right, then I believe all of you already downloaded the course lab material, the lab material, and the answer sheet and the data file. So then let's get started. And this is our lab material. So again, in this video, we are going to learn how to do the logistic regression with the real data. Okay, first of all, just let me briefly introduce what is the underlying story in this lab. So there's a company, the company XYZ, and this company is very similar to Amazon. So just simply think that this company is kind of the online merchandise, the marketplace company. And this company introduced a new premium service, which is called the Super Account Service in 2017. And this service is an annual-based service. And so the customer the contract and subscribe this account just for 1 year. And then this service provides kind of the quick delivery, the expedite delivery service to the super account users. So this is very similar to Amazon Prime membership. So the Amazon just provide a very, very quick delivery service to the Amazon Prime member, right? So we can get just the 1-day delivery or the same-day delivery, even the same-day delivery from the Amazon sellers if we are the Amazon Prime membership, Amazon Prime service user, right? So just simply think that this service, the super account service, is very similar to Amazon Prime membership. And in 2017, the company sent the direct mails to the customers multiple times to advertise this service. And then the company, the service manager, gathered the customer's response data and the customer's demographic data and the data. And what the marketing manager really wants to know here is twofold. So first, how many direct mails should be sent to the customers to maximize the profits in 2018 from the super account service? And which types of, and to know this, to investigate this, the manager may have to know which types of customers. So the customer's profile, the profile of the customers who are highly likely to apply, highly likely subscribe this new service in the next year, 2018. Okay, so if we know the profile of the customers who are highly likely to subscribe this, then we can make a prediction, right? We can make a prediction. Then, based on the prediction, we can determine the optimal level of the mail or optimal the number of the mail flyers to be sent out to the customers. Okay. Then, just let me introduce the variables in the data first. This data include 1,000 customers with the 7 variables. So just let me open the data. This is our data. Okay. So there are 7 variables. And the first variable, ID, that is the customer identifier. Okay, so here we have 1,000 customer, right? And we have additional 6 variables. The first variable, the choice 2017, this variable indicates whether each customer subscribed the super account service in 2017 or not. Okay, so 0 indicates, oh, this customer, yeah, didn't subscribe the super account service in 2017, and this 1 indicates, oh, this customer 3, subscribed and used the service in 2017. Okay, and the the service manager has this kind of a conjecture. The first conjecture is that, oh, maybe if a customer has very high income level, okay, earns a lot of money, then this customer is highly likely to use this kind of way, the convenience service. Okay, this makes sense, right? So yeah, if I have a lot of money and then just getting the product quickly is really good service, I really want it, that is more convenient. So if I have enough money, yeah, there's no reason to just not use this type of a service, right? I have to and I must, yeah, use this service to get the product a little bit more fast, right? And the second conjecture is that if a customer is frequently using or frequently purchasing the product from the company XYZ, then maybe the customer is highly likely to use this kind of a service. So the number of purchases, the number of transactions made by the customer is really, really high. And then that high level of the transactions, high level of the purchases incentivize the customers to use this super account service with the fast delivery, right? It makes sense, right? And the third variable, the third conjecture is about our marketing effort. So this end mail 2017 is the number of mail flyers sent out to each customer. So here it is 3. That means the first customer received the mail flyer from the company 3 times in 2017. Here, customer number 4, this guy received the mail 4 times during 2017. Okay, so and the basic conjecture is, oh, if a customer received more flyers, then the customer is highly likely to use the service, highly likely to subscribe the service, because yeah, this customer is exposed to the service a little bit more, right? And more. So the service manager has these 3 conjectures, and those make sense, right? So with this data, yeah, we are gonna first confirm, yeah, the service manager's conjectures first, okay? And we are gonna make a prediction for the customer's choice in 2018 with the previous year data. Okay, so here this choice 2017 variable is 0 and 1 binary variable, right? We want to predict the the customer's choice in 2017, yes or no, buy or no buy, subscribe or not subscribe. And then to explain why each customer choose the service, or why this customer did not choose the service, the service manager is using one demographic variable, that is the income 2016, and one the past history, past transaction variable, past observation variable, and the firm's marketing effort, that is the firm's decision variable. Okay, so the service manager is using these three types of the variables, okay, to explain the customer's choice of the usage of the service, right? So that's the basic structure. That's the basic structure of the story in this lab assignment. Okay. The variables to be used to explain are independent variables. So we learned the basics of the logistic regression, basics of the regression in our lecture video, and these type of variables are called independent variables. So we are gonna explain a certain behavior through these variables, okay? And what we want to explain, that is this choice, the customer choice, that is dependent variable, okay? So we are gonna use the logistic regression. Why? The dependent variable is 0 and 1 binary variable, okay? And we use the logistic regression to explain the customer's binary choice through these three independent variables, okay? That's the basic underlying story of this project. And just let me explain one more thing here about the variables. So to explain the 2017 choice, here the manager gathered the customer's income in 2016 and the purchase history in 2016. Why? Why the managers use the previous year data? Because we need to, in the next step, we need to make a prediction for the next year. Then we need, if we were using the same year data for the income, same year data for the frequency, then it means that we don't have these two variables for the next year prediction. So if we were using income 2017, frequency in 2017, then to make a prediction for the choice in 2018, we need the income 2018 and frequency in 2018. But income variable and frequency variable, they are not available as of 2018, the January 2018, right? So maybe the customer's income level does not dramatically change over the years, and the customer's just the purchase frequency does not dramatically change over the year. So assuming that we can just use the previous year information about the income, about the frequency as kind of by the proxy, the approximation of the customer's income, the current income, and customers the propensity of using or the purchasing the product from this website, this service, right? So that's why we are going to use the income variable and the frequency variable in the previous year to explain the choice in the current year. And here, main variable, that is the firm's decision variable, right? So because this is a firm's decision variable, we can, it is available, the same for the same year, with the customer's choice, okay? And even for the 2018, so we are gonna make a prediction of the customer's choice in 2018, then maybe, as of January 2018, we don't have a main variable in 2018 because as of January 2018, the company has not yet done any marketing action, any marketing activity. So there's no ML variable of 2018. But at this moment, and for the purpose of the optimal, for the purpose of optimizing for the purpose to find the optimal number of the mail flyers to be sent out, we don't need that variable. We are going to do kind of the simulation if the number of the mail flyers to be sent out is 0, is 1, is 2, and 3. And then we that suppose that just we are going to send the mail flyers to the customers just one time, or just 2 times, or 3 times, and then what would happen? That's the goal of the prediction. Okay. So we are going to do this. So at this moment, we don't need to gather this nmail 2018 variable for this project. Okay. To dive into the main analysis, just let me sum up the purpose of this lab assignment and this project. So here, this briefly explains what we are going to do. Again, we have these 3 independent variables: income, frequency, and then mail. And we have the dependent variable, the binary dependent variable. And we are going to explain why and what kind of a customer is highly likely to use the super account service with the 2017 data. From this analysis, we can get the parameters of the logistic regression model, that is these betas: the beta 0, which is the baseline parameter, and beta income, which is the multiplier of the income variable, and the beta frequency, which is the multiplier or coefficient of the frequency variable, and beta m mail, which is the multiplier or coefficient of the m mail variable. So from this estimation step, this first analysis of the logistic regression, we can get the values of beta 0, beta inc, and beta frequency, and beta m mail. And then we are going to use these values of beta in the prediction step. And what we are going to predict, that is the customer choice in the next year. And we know this beta baseline, we know the beta income, we know the beta frequency, and we know the beta n mail variable. And we have the customer's income level in 2017 as of 2018. And we know how many times the customers made the transactions in 2017. We don't know the marketing effort. But the purpose, the managerial problem is that how to determine the number of the mail flyers to be sent out. What is the optimal number of mail flyers to be sent out? To do that, we can do kind of a what-if analysis or simulation study. If no flyers are sent out, that is, the m mail 2018 is equal to 0 for all the customers, then what would happen? Okay, we can make a prediction in this case about how many customers do subscribe the service. And this number, from this number, we can calculate the expected revenue. And we can also compute how much does it cost, this marketing activity. Here, no flyers, it means that no marketing cost. So in this case, the cost is equal to 0. What about if we send out the flyer to the customers only once for all the customers? Then it means that the ML variable is gonna be one for all the customers, and then we can make a prediction, right? Then with that prediction, we can compute the expected revenue. Also, we can compute how much does it cost. Then, yeah, with the revenue, expected revenue, and with the expected cost, we can do revenue cost analysis. We can do this if we send out 2 of mail flyers to the customers. Then what would happen? If we send out the mail flyers to the customers 3 times, what would happen? 4 times, what would happen? Then with this series of the simulation, we can do the revenue cost analysis for each case, and then we can find the optimal number of mail flyers to be sent out to the customers. So that's the basic structure. That's what we are going to do in this lab. Okay, then let's get started. Okay, so here, yeah, we have the data here. Then the first step again, yeah, we are going to do the estimation. The estimation of the logistic regression, yeah, it can be done in SPSS. So to do that, we need to open SPSS first. So just please open SPSS here. Yeah, I have SPSS here. All right. When you open SPSS, yeah, you may face this welcome window. Yeah, just ignore this by clicking this close. Okay. Then you may have this the data window. Okay. SPSS has 2 types of the windows. One is this data window, and the other one is the output window. Okay. In this lab, you must submit 3 different files, which is different from the previous lab session, right? In the previous lab session, you just need to submit your answer sheet and Excel file. But here in this lab, you need to submit 3 different files. One is Excel, the other one is the answer sheet, and the last one is the save file of your output image in SPSS. Okay, so once you analyze something in SPSS, and then SPSS show the output window with the several tables and the figures and something like that, and then you need to save that output, and then you need to submit that output file. Okay, and in the middle of the video, I'm going to explain how to save the output file. All right, maybe some of you are familiar with the SPSS, but some of you are not, right? So for those guys, let me briefly just introduce the SPSS. So this is the data window, and this is very similar to the Excel spreadsheet, right? So this data window just show the data in this table shaped window. Because we've not yet loaded any data here, so we don't have any data. So let's try. Let's first import the data from the Excel to the SPSS first. Okay. To do that, please go to File menu, and you can find the Import Data and click Excel, because our data file is Excel file. And then just navigate to the folder where you downloaded your data file. Yeah, I just downloaded data file in this folder. So I have the Excel file here. Okay, superconsdata.xlsx, and click this file and press the open button. if you cannot find this file, even though you just are in the correct folder, just please check the files of the type. This should be Excel. Okay, so if your type is different from Excel, just click this, and then you can find the list of the file, the types, and then click this Excel type. Okay, and then you can find your data file. Okay, and click your data file and click open. Then you may see this read Excel file dialog. SPSS automatically detects the range of the data in Excel. Okay, you just need to designate which worksheet. Okay, so let me go back to Excel. So here, sheet number 1, we have the data in sheet number 1. So sheet number 1, we need to choose the sheet number 1. Maybe that is only one option. Then here you can see the preview of the data here, right? So lots of the variables here. Okay, so it looks good, and then just click OK button. Then you may see this output window. That is the output window. Okay, so we do something. We just loaded the data, okay, into the SPSS. We do one thing. So in each step, SPSS just provide this type of output. Okay, and just simply ignore this output. And this is the data window with our data. Okay, so here we have ID, choice 2017, income 2016, frequency 2016, and mail, income, frequency again, right? So all 8 variables are well loaded in SPSS, right? But just right before of the variable name, you may find some icons, right? So ruler and 3 circles, ruler, 3 circles, right? Ruler indicates the variable is the interval variable. It means that the numeric number here, 1, 2, 3, those numeric number has its own meaning. 1 is greater than 2, right? 2 is greater, 2 is greater than 1, and 3 is greater than 2, okay? And the difference between the 2 and 3, that is 1. That size of the difference has the meaning. Okay, when we compare 2 and 4, this is 5, 2 and 4, then the difference between these two numbers is 2. That is different from the difference between 2 and 3 because this difference is only 1, right? So if the numeric information in the variable has its own meaning, then in that case, we call that variable the interval variable, okay? But let's look at choice 2017. Again, this is a binary variable, and in this variable indicates whether each customer just use the service or not. 0 indicates not subscribed. 1 indicates subscribed. Here, 0 and 1, those numbers, those numeric numbers do not have any meaning. We can just replace it, okay? We can use 1 instead of 0 to describe no subscription. We can use 0 instead of 1 to describe subscription, right? It's our choice. And here I just choose 0 for no subscription, 1 for subscription, okay? So here I am, and we are using the numbers 0 and 1 to distinguish between the subscription and the no subscription. It means that we just categorize the value of this variable by the use of these two numbers, 0 and 1. So this 0 and 1 does not have any numeric meaning. It just has the categorical meaning. So in that case, we call this type of variable as categorical variable. Income, rule again. It means that this variable is designated as the interval variable, and it makes sense, right? This is an income level. Yeah, maybe just every the unit of this variable is $1,000, maybe. So the first customer, his or her the annual income in 2016 is about $147,000. Customer 2, $94,000. Customer 3, $104,000. 4, 103. So it has its own meaning. 104 is greater than 103, and 147 is greater than 104, right? So this variable should be the interval variable. So this is correctly detected. And how about the frequency? This is the number of the transactions, right? So it should be interval variable, but it is detected as the categorical variable, right? So it's wrong. We need to correct this. How about MAO? This variable should be interval variable again, because this is the number of the mail flyers sent out to the customer, right? So 3, it means that 3 times. 4, it means that 4 times. It has its numeric meaning, right? So this variable should be interval variable. Income 2017 again should be numeric, the interval variable, and frequency 2017, it should be the interval variable as well. So except for the choice to actually the ID, we are not going to use this variable, so it doesn't matter. So we don't need to think about the types of the ID variable, but except for choice variable, all the other variables should be interval variable. Then how to change the type of the variable? To do that, we need to go to the variable view. Here at the bottom of the data window, you can see these 2 buttons, and then click this variable view. Then you can see the information of each variable. And then let's go to the measure tab. That is the type of the variable, okay? Then here, choice 2017, that is nominal. Nominal means the categorical variable. Income, that is the scale. Scale means the interval variable. So choice 2017, this should be nominal, and all the other variables should be scale. So click this nominal for the frequency, then you can see options. Just click scale, okay? And click the next nominal, click scale. The next one, click scale, okay? Then you can see all the types of the variables, all the other variables are correctly set. All right, and then go back to the data view again. Then you can see all the icons of the variables except for the choice 2017. Correctly change it. All right, then let's run the logistic regression with this data. Again, our goal is that in SPSS is the estimation of the logistic regression. And what is the dependent variable? That is choice 2017. And what are the independent variables? Income 2016 and frequency 2016 and MAO 2017. So we are going to use these 4 variables. And please keep in your mind. And then let's get started. So please go to Analyze menu. Then you can see the regression. Logistic regression is just one of the regression methods, okay? So we need to go to the regression, and then here we have the binary logistic. Our dependent variable is a binary variable, so we should use the binary logistic regression model. So click this binary logistic. Then you can see this logistic regression dialog. Here, this dependent, we are going to designate the dependent variable here, And here covariates, that means the independent variable. So we are going to designate the independent variables here. So what is our dependent? That is choice 2017. So click this, choice 2017, and click this arrow next to the dependent, the text box. Click this. Then, yeah, the choice 2017 is successfully set as the dependent variable. And we are going to use the income 2016 as one of the independent variables. So click this second arrow button. And frequency, that should be the next independent variable. So click the second arrow button again. And mail 2017, that is our last independent variable. So click this second arrow button again. Then these three variables are successfully set as the covariate or independent variables. And that's it. Now you just need to click OK button. OK. Then you can see the logistic regression result. Sometimes it takes a couple of seconds, but yeah, mostly you can get the result immediately. Right. And this is output window, and this is what you have to save. Okay? So just try to interpret, just try to navigate the tables and the figures in this output. Please save this output file first. How to do that? You can see the diskette icon here in your output window, not in the data window. You have to find the diskette button in the output window, and you can see this diskette button and click this diskette button. Then you can save the output file. The extension of the output file is SPV. So please keep this extension name in your mind. Okay. Yeah, for your convenience during the submission. And the file name, anything is okay. So I'm going to use go to Lab4. Okay. And click save button. And this output file is saved. And that's it. Okay. Very simple, right? And then now let's look at the result. Go down and go down and go down and go down. So just go to the bottom of the output file and then the output image, and then you can see this table variables in the equation. This is table you have to look at. Okay. We have three independent variables: income, frequency, and mail. But there is one more thing, constant. That is the baseline. Okay, let's go back to just my brief introduction of what we are going to do here. So here we are going to explain the customer's choice by the use of the income variable and frequency variable and mail variable. And we have one more thing here. That is the baseline. Okay. If this value is high, it means that, on average, the customers are highly likely, just basically highly likely to use this service. Okay. If this value is low, it means that on average, basically, just regardless of all the other variables, the customers are basically not likely to use this service. Okay, so that is the meaning of the baseline variable, baseline parameter. So here, this constant row is all about this beta 0. All right, and now we need to interpret this table. In this table, you just need to use two columns. One is the column B that contains the estimates of the parameter values, and this second column that provides the p-value of the estimates. Okay, then now let's open your answer sheet file. Okay, here's the answer sheet file, and the first question, is to fill out the estimation result. Okay, in SPSS, this table shows the estimation result, so you need to refer to this table, but only two columns. Again, B and C, and B column contains the estimate, and the C column contains the p-value. So you can fill out this table, but please be careful. In the table, the constant is the top in the table. That is the norm. That is the norm. Always the constant or the baseline should be in the top of the table. That's the norm of analysis report. But I don't know why in SPSS, SPSS is very unique. So SPSS, to my limited knowledge, SPSS is the only one software which show the constant in the bottom of the table, not in the top of the table. Okay, I think that's very weird, but I don't know why. But that's SPSS. So please be careful to refer to the SPSS estimation table. So this negative 1930, negative 1.930 should be in the first row, in the table in your answer sheet. All right, so here we know that the constant value, the baseline value, is negative 1.93, and the income variables coefficient, each estimate is 0.01. For the frequency, the estimate is 0.137 and ml 0.214. So it means that this beta 0 is estimated to be minus 1.93. And this beta INC, that is income, so 0.01. And beta frequency, that is 0.137. And nail, that is 0.214. That's the estimate. And we have one more information. There's a p-value in this C column. What does the p-value mean? Here, let's look at the constant first. The p-value of the constant is 0.000. 0.000 means that it is very, very, very close to 0. It is just a little bit greater than 0. Okay? And that is, the p-value means that basically the p-value is a probability, and the p-value means the probability that just if we observe that this kind of way data, assuming this constant, this baseline parameter is equal to 0. Okay? So assuming that this beta 0, this parameter is equal to 0, then what is the probability of observing our data? That probability is 0. Okay? There's no chance to observe this data when we assume this baseline parameter is equal to 0. It means that the baseline parameter should be different from 0, right? When we just assume this is 0, then we have no chance. It means that we have not to assume, or we have to assume, or we have to conclude this is different from 0. Right, all right? So usually, we are going to use the 95% of the confidence interval, okay, or the confidence level. It means that if this p-value is smaller than 0.05, and then we can conclude that this estimate is significantly different from 0. It means that this estimate has the statistical meaning. statistical meaning itself. And let's look at the other estimates. For the income, each estimate is very, very small, just 0.01, very small, but still this value is also significant because the p-value is equal to 0.000, that is smaller than 0.05, right? For the frequency variable and main variable, all the estimates are statistically significant. So we can use all those values, to make a prediction, right? Because they are statistically significant. Okay, that's the meaning of the p-value. And now, we have those numbers. And that's all of what we have to do in SPSS. Then we are gonna go back to Excel to make a prediction. Okay? Then in the prediction, what we are gonna make a prediction for? That is the customers, the choice of the super account service subscription in 2018, right? Then to make a prediction for this choice, we are gonna use the beta values we got the estimation. So that is the minus 1.93 for beta 0 and 0.01 for beta income, 0.137 for beta frequency, and 0.214 for beta and mail. We're going to use these values, and we're going to use the independent variables for the 2018 choice. That is the income variable 2017. That is the frequency variable 2017. Okay? So first, we're going to go back to Excel, and then we're going to use these two variables, income 2017 and frequency 2017. And we don't have ML 2018, but as I told you, we are going to do the simulation. Okay? We're going to assume ML 2018 is equal to 0. It is equal to 1. It is equal to 2 and 3. And we are going to make a prediction for the choice 2018. Okay, so that's what we are going to do. Okay, and then let's go back to Excel. So here, we are in Excel. Then again, we have the income 2017 and frequency 2017. What we don't have is the ML for 2018. So we need an additional variable for ML 2018, right? And we are gonna make a prediction for the choice 2018, but to make a prediction, we need 2 more variables for the computation purpose. They are odd and proud. We need these 2 more variables for the computation. And then the next one is choice 2018, which contains our predicted value. Okay. All right. Then let's get started. First, let's just assume that we are not gonna send out the mail flyers to the customers. That means we are gonna assume the mail 2018 is equal to 0 and 0. Okay, so just put 2 zeros in the first 2 cells, and then select these 2 cells. And then move your mouse cursor over this small rectangle button, and then double click it. Then all the numbers, all the cells are filled with this number 0. Okay. Then now we need to compute the odds and probability. And what the heck? What is odds and what is probability here? All right. For your better understanding, just let me open our lecture note. Here, yeah, we have the lecture note. Maybe around here. Uh-oh. Yeah. We need to compute this loaded function. And yeah, as in the my lecture video, this loaded is very complicated function, looks like this. exp, what is it? Don't worry about it. You don't need to understand the mathematical form of this logistic regression and this loaded function. You just need to how to compute this loaded function. Very simple. First step is compute odds. Okay, and odds is given by exp. What is it? You don't need to know this. Okay, you can just simply compute the exp function in Excel in the same manner. You just need to type exp and that's it. Okay, you can get the number. Yeah, you can get all the number. Okay, so don't worry about it. And exp all the equation in this loaded function. That is this. Okay, that is this. So this is our prediction, and let me show the details here. This is our prediction, and to make a prediction, we first need to compute this loaded function. Okay, and we can compute this loaded function through the two steps. One is odds. That is given by exp this. Okay. The next step, probability. Probability, that means this predicted probability. This predicted probability can be computed by dividing odds by 1 plus odds itself. Okay. And that is the probability. Then, oh, I'm sorry, not the 2 steps, 3 steps. Then, if probability is greater than 0.5, then choice 2018, we are gonna make a prediction of yes, okay, for the customer. If not, if probability is smaller than 0.5, choice 2018 becomes 0, no subscription. Okay, that's the basic step. And here we know the beta 0, that is, negative 1.93, and beta income 0.01, beta frequency 0.137, and beta and negative 0.214. So we're going to use these values for the betas here. Okay, that's our step. And let's go to the answer sheet first. Here in the answer sheet, yeah, we have very similar equations here. The question number 2 asks how to compute the how to make a prediction, yeah, through in Excel. So yeah, this is the totally same as what I explained. So we first need to compute odds, that is exp of something plus something plus something and plus something. Here, beta 0, again, that is negative 1.93. So this question is asking about what is the value of beta 0? Okay, you can refer to your table here to fill these blanks. Right? And beta 1 is 0.1 like this. Okay, so just you can simply fill out the blanks here with the actual estimates number. All right, that's what you have to do in the question number 2. Just very simple. Okay. All right. So, oh, sorry. So let me finish the equation here. This should be exp, this minus 1.93 plus 0.01 times income 2017 plus 0.13, what? 0.137 times frequency 2017 plus 0.214, maybe 214, right? Times N male 2018. Okay, that's what we are gonna compute in Excel. Okay, so let's go back to Excel. Here is Excel. Okay. Okay, odd, that is this exp. Okay, so let's make an Excel equation. Okay, just type the equality mark first to start the Excel equation, and again, which function we're going to use? exp. That is exp. So write down exp here and open a set of parentheses. Okay, and the first number is baseline. That is minus 1.93. So minus 1.93. Okay, and the next one is this plus. Okay, so plus. The next one is the coefficient of the income. That is 0.01. So type 0.01. Okay, be careful. Yeah, in between 0 and 1, there should be 1, 0. Okay, sometimes some students just miss this 0 here, and then that makes the result is very weird. Okay, so please be careful. And what's next? The multiplication. In Excel, the multiplication is asterisk mark. This. So press this asterisk mark. And the next one is income 2017. Okay, this is a variable. And where is the income 2017 variable for the first customer? That is F2. So click this F2. Okay. And then plus the next variable is the frequency, and its coefficient value is 0.137. Okay, so 0.137 and multiplication. And where is the variable? G2. Okay, so click G2. And plus, what's the next? N male. Okay, and its coefficient value is 0.214. So type 0.214 and times, where is the N male variable? That is H2. So click H2. And close the parentheses. Close. And just press enter. Okay. So just let me show this equation again for your convenience here. exp minus 1.93, that's the baseline coefficient, plus 0.01, that is the income variable coefficient, times the cell number of the income variable for the first customer, that is F2, plus 0.137, that is the coefficient value of the frequency variable, and times G2, which is the cell number of the frequency variable for the first customer, okay, and plus 0.214, that is the coefficient value of the N male variable, and times H2, that is the cell number of the N male variable for the first customer. And close the parentheses and press enter. Then now you get the odds value. Okay? And just move your mouse cursor over this small rectangle button and double click it. Then you can compute the odd value for all the other customers like this. The next step is the probability. Again, the probability is very simple. you just need to divide the odds by 1 plus itself. Very simple, right? So we just type this equation in Excel. That's it. So press equality mark to start the Excel equation and select odds value for the first customer. That is I2. And we are going to divide this by, okay, so press slash for division and open the parentheses. 1 plus odds again, I2 again, and close the parentheses. Okay, and press enter. Then you can get the probability value. Okay, this is a probability. So this number should be in between 0 and 1. If you get the number which is smaller than 0 or which is greater than 1, it means that there's something wrong. Okay, so please go back and then please double check everything again. Okay, so this probability value should be in between 0 and 1. And move your mouse cursor over this small rectangle button and double click it, then you can get the probability value for all the other customers like this. Okay. Then the next step is just make a prediction based on the probability value. Okay. Okay. If this probability value is greater than 0.5, then our prediction is gonna be 1. Oh, this customer is predicted to choose the service in 2018. Here, this is greater than 0.5, right? So this customer choice is predicted to be 1. Okay. To make this prediction, we can use if statement. So press equality mark and type if, okay, and then open a parenthesis, okay. Then we need to put the condition. This J2, the probability, so click this probability value, J2 is greater than 0.5. And press, there is a condition, and press comma. After the first comma, we are gonna put the value if this condition is true. Okay, so this condition greater than 0.5. If it is true, we are gonna put 1 as our prediction, and put another comma. And after the second comma, the value if this condition is false. It means that this probability is smaller than 0.5, and which value this variable has. That is 0, right? So put 0 here, and then close the parentheses. Close. And press enter. So this probability is greater than 0.5, so we have 1 here. And move your mouse cursor over this small rectangle button, and then double click it. Then you can get the prediction for all the other customers. So this is a prediction step. Okay, now we can get the prediction. Then let's go back to the purpose of this analysis, this project. The managerial problem is that to find the optimal number of main flyers to be sent out. To do that, we are going to do the what if analysis or the simulation study if no flyers are sent out, if 1 flyer is sent out, if 2 flyers are sent out. Okay, that's what we are going to do. And we've just finished the first simulation. If no flyers are sent out, and what would happen? Here, this prediction is what would happen. Okay, then let's do this revenue and cost analysis for the first simulation case, the first case, no flyers. Okay. Then to do that, we need to make a new spreadsheet. So click this plus button to make a new spreadsheet. Okay. And just let me zoom in. make these 5 variables: mail, host, response, revenue, and profit. Okay. First, in the simulation, we just assume that the no flyers, are gonna be sent out to the customer. 0, right? So the first case is MA is equal to 0. Then the cost should be 0, right? There's no mailing cost because we don't send any mail flyers, right? And how about the response? That is the number of the customers who are expected to subscribe the service. How to get the number of the customers? That is the beauty of this 0, 1 binary variable. Here, 0 indicates no subscription. 1 indicates subscription. Then, when we just compute the sum of this choice, this prediction over across all the customers, okay, and the sum is the same as the number of customers who are expected to subscribe the service, because 1 indicates subscription, 0 indicates no subscription, right? So to do that, you just need to click this column number K. So here, move your mouse cursor over this K and click this column. And then let's go to the bottom of your Excel. Here, the very bottom, you can see the sum of the selection. Here we have this column K, and this text is ignored when the summation is computed. So here you can see 204. That is the sum of the prediction. That is the number of the customers who are expected to subscribe the service. Okay, so 204. I'm sorry. So move to the sheet number 2. The response is 204. Okay. Then, now let's do another simulation. What if we send out the mail flyer to the customers 1 time? Okay, so mail is equal to 1 case. Then we need to make a prediction again. And this is very simple. Just go back to your sheet. Okay, you just need to change the values in column H from 0 to 1. Okay, so to do that, just change the MA value for the first customer from 0 to 1. Just type 1 here. Then you can see the change in odds value and the probability value automatically. And still the choice is equal to 1. Then move your mouse cursor over this small rectangular button and then double click it. Then the ML variable for all the other customers, change it to 1 from 0. And then all the other things, the odds value and probability values, change it, and the choice is automatically change it. Then you just need to compute the sum of the choice variable by clicking this column name K. Then the sum is 380. It means that if we send out the mail flyers to the customers once, then 380 customers are expected to subscribe the new service, this super account service. Okay. The cost, I'm gonna compute the cost and revenue just after all the predictions. And what if the ML variable is equal to 2? Very simple. Go back to the sheet, okay, and change this from 1 to 2 like this, and double click. Then you can see the change of the choice variable to choice prediction, and click this column K, then you can see the sum, 592. Okay, so go back to sheet 2. The response, 592. It means that if we send out the mail flyer to the customer twice, then 592 customers are expected to subscribe the super account service. 3, very simple. Just go back to the sheet and change this from 2 to 3. Okay, and double click the button. Then you can see the change in the trace prediction, and click this column number K, column name K, and the sum is 768. That is the number of the customer. Oh, sorry. That is the number of the customers. Oh, what is the value? 768. So this is 768. It means that if we send out the mail flyers to the customer 3 times, then about 768 customers are expected to subscribe the service. What if 4? Let's do it. This should be 4. And double click this. And click this column K. 906. Almost all customers, right? So, oh, sorry. Sheet 2. This is 946. All right. Just stop here. Okay. When we put 5, and this is going to be 1000. Okay. And then in that case, yeah, we may see not the best result. Okay. So just stop at 4. Okay. Just do the revenue cost analysis for these 5 cases. Okay. And then now we need to compute the cost and revenue. Okay, for the cost, we have 1000 customers. Okay, and then just assume that the cost per each mail is just $1. So if we send out the mail to the customers only once for all the customers, then we need to send out the 1000 mail, right? So that is, press the equality mark, 1000 mail, okay, because we have 1000 customer, times the number of the mail flyers to be sent out each customer. Okay, there's 1 here. And the unit price is $1. So we need to multiply 1 again and press enter. So the mailing cost is, in this case, is 1000. And just double click this. Okay. If we decide to send out the mail twice to the customers, all the customers, and then the mailing cost becomes $2,000. $3,000 for 3 times, $4,000 for 4 times. Okay, very simple. And what about the revenue? Suppose that $5.5 is expected to each of the super account service users. Okay, so the revenue becomes the number of the customers expected to use the super account service. So that is C2 times per each customer. Yeah, we expect $5.5 revenue. So $5.5, and press enter and double click this. Okay. Then this is the revenue and this is the cost. And what is the profit? Profit is given by revenue minus cost. And press enter. That is the profit. Double click this. Then now we have the expected profit, okay, for each case. And what is the optimum? What is the best profit? This. 1256. when we send out the mail flyers to the customers twice, we expect about $1,256, and that is the optimal profit, the best profit we can expect. So this number 2, that should be the optimal number of mail flyers to be sent out. Okay, so we can decide 2 and go back to our answer sheet. Let's look at the third question. Referring to your table of expected profits, how many times should the direct mail be sent to the customers to maximize profit? That's what is the answer? I already explained it, right? Question number 4. Okay. Your answer to question number 3 is the optimal number, blah, 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 with the when the cost per mail is $1 and expected margin per customer is $5.5. What if the expected margin goes up to $6 from $5.5? It means, all right, go back to your Excel. The revenue structure is a little bit different. So the per customer, the expected margin is not 5.5. It is now 6. So replace this 5.5 with 6. Okay. Then press enter. Okay. And then we need to replace. We need to modify all the other cells here in this column B. So just double click this small rectangular button. Then you can see the updated revenue, and the profit is automatically updated. In this case, optimize change, right? So the maximum profit is $1,608 when the MA is equal to 3. Okay, so when the revenue structure changes, the optimal number of email flyer, the value of the decision variable can be changed, right? Then I think you can answer this question. And the last question, what if the mailing cost goes down to 0.75? Here, still, you need to assume that the expected margin per customer is 5.5. So you need to answer this question, you first need to roll back the revenue, okay? So it should be 5.5 again. And double click this, okay? And then here, the cost goes down to 0.75, okay? So now this should be replaced with 0.75, okay? The unit cost is 0.75. Then double click this, then the cost is updated and the profit is automatically updated. And in this case, 4 times. That is the optimal. Okay, so now you can answer the last question. All right, that's all I have in this lab. Please save this Excel file, okay? Please save your Excel file. And again, if you've not saved your SPSS output file, please save this output by clicking this escape button, okay? So save your SPSS output file, save your Excel, and complete your answer sheet, and then submit these 3 files. Okay, that's what you have to do. All right, and then enjoy the remaining week, and see you next time. Bye-bye.